Welcome to this explainer. Okay, imagine looking up and seeing a bizarre distortion in the sky, and it's moving at the absolute speed limit of the universe. Let's dive right into a seriously terrifying cosmic hypothetical.
So, what if a black hole actually pierced Earth at light speed? Well, if this impossible collision ever happened, the destruction would scale up from just plain bad to unimaginably catastrophic. To really grasp the physics at play here, we're going to examine 4 different sizes of black holes and watch how the chaos escalates with each one.
Section 1. The coin-sized planet killer.
To understand our very first and technically smallest threat, we have to look way back, like 13.8 billion years back. Scientists theorize about these things called primordial black holes. Basically, they're tiny, dense pockets of extreme gravity that formed right after the Big Bang, before galaxies or planets even existed. Get this, they could be as incredibly tiny as a single atom, but weigh as much as an entire mountain.
Now check this out. The sheer, mind-bending density here is just wild. We are talking about a black hole with the immense mass and gravitational pull of our entire planet, completely compressed into a sphere less than 2 centimeters wide. The entire weight of our world could literally fit right in your pocket.
So what exactly happens when this little coin-sized visitor hits us at the speed of light? 0.04 seconds. That is it. That's about 10 times faster than the blink of an eye. In that tiny, fleeting fraction of a moment, this cosmic bullet would pass completely straight through the Earth.
You literally wouldn't even see it coming. Before you could react, it would punch this narrow, collapsing tunnel straight through the planet. We're talking simultaneous global earthquakes, entire tectonic plates shifting all at once. And anything in its immediate path, well, it would undergo spaghettification, which is a fun word for a terrible thing where matter is literally stretched and ripped apart like noodles by extreme, localized gravity.
Section 2. The stellar mass bullet.
All right, let's scale things up a bit and see how the destruction builds. We're now dealing with a destructive force packing the mass of 10 suns. But it's totally squeezed down to just 37 miles wide. Think about that. It's a sphere you could drive across on the highway in under an hour, but its gravitational shadow is strong enough to shred entire planets. Since this thing is barreling toward us at roughly 300,000 kilometers per second, we'd get a very brief, utterly terrifying warning as our outer planets are violently disrupted. 5.5 hours out, it enters the outer Kuiper belt. By T-4 hours and 50 minutes, you'd literally watch Jupiter experience massive tidal disruption. And just 30 minutes after that, Mars is completely torn apart by tidal forces, or just flung right out of its orbit.
As it closes in on us, you would witness a terrifying optical illusion known as gravitational lensing. The extreme gravity is actually distorting the very fabric of space, bending light itself. The familiar night sky would violently warp, and the stars would appear to swirl into this crazy vortex right before impact.
Now here's the absolutely crucial point. Earth wouldn't just be swallowed whole. A head-on, light-speed collision would violently rupture and deform the planet. The crust, the mantle, the core, all pulled inward. The oceans would boil, the atmosphere would ignite, and Earth would be left bleeding a trail of superheated, collapsing matter out into space while the black hole just keeps right on going.
Section 3. The intermediate monstrosity.
Okay, scaling up yet again to something incredibly rare. As you can see, we are now dealing with an object of immense physical size, dragging an unfathomable amount of gravity into our neighborhood. Imagine the mass of 1,000 suns, packed into a beast about half the physical size of planet Earth.
The physics here literally break our reality. Because of this massive gravity, it wouldn't just collide with Earth. It would replace the space where Earth used to be. The entire planet would collapse inward, rocks lifting up, the ground curving, and vanish in a fraction of a second before the black hole even technically touched the surface. But here's the kicker. Because extreme gravity actually warps time, a phenomenon called time dilation. From an outside perspective, time near the event horizon would appear to come to a complete standstill.
Section 4. Phoenix A star. The Destroyer. For our final escalation, we meet the baddest, most stupendously massive black hole ever discovered in the observable universe. 100 billion suns. I mean, that number is just incomprehensible. It's a gravity well so incredibly deep that it turns our entire solar system into a mere speed bump.
To put that staggering size into perspective, the event horizon alone, the point of no return, is 590 billion kilometers wide. That is 100 times the distance from Pluto to the Sun. It is a cosmic death trap so gigantically massive that it would swallow all the planets in our solar system at once like they were absolutely nothing. Let's walk through the steps of this system-wide annihilation, which actually begins to warp Earth's orbit long before this absolute monster even reaches the Kuiper Belt. Neptune and Uranus drift right off their orbits. As it approaches at light speed, the gravity is so immense that Earth's oceans would literally bulge upward into the sky. Supersonic winds would tear across every single continent as the atmosphere is ripped away, and satellites, including the International Space Station, would plunge into a death spiral.
Then, the flyby. In a flash of just 0.04 seconds as it passes, the black hole's gravity would suddenly and completely overpower our sun's. Earth's orbit completely shatters. For a brief, terrifying moment, it would feel as if gravity just disappeared, lifting people, cars, and buildings right into the air. And this is immediately followed by a sudden, violent global freefall as the planet erupts into simultaneous volcanoes and earthquakes.
And in the aftermath, it's a chilling reality. Phoenix A star permanently alters the solar system. Our sun's gravitational hold is broken forever. As this quote points out, whatever remained of Earth would become a rogue planet drifting through space, not bound to any star, leaving humanity's remnants cast out into the interstellar dark.
Which leaves us with this final, lingering question to ponder long after this explainer ends. Even if you miraculously survive those 40 milliseconds of absolute earth-shattering chaos as the black hole ripped through our neighborhood, could you adapt to the existential deep freeze of a rogue planet drifting away from the sun forever?